function f of x is called an antiderivative if the derivative equals the original function. So if capital F is an antiderivative of lowercase f, most general antiderivative is here. That's just everything we've learned from our text about what an antiderivative is. If we have capital F, then its derivative should be the function that we're starting with in the first place, lowercase f of x. Okay, so they want the general form. So if you have x to the n, the antiderivative is plus 1 for power, but then you need to make sure that plus 1 cancels out when you take a derivative so that it turns back into the original function. Okay, so suppose it's the antiderivative f of x, the general form, if this is k. So if k is a constant multiplying to your function, when you take an antiderivative, k is still multiplying at the end. That's what it's emphasizing there. Okay, now they want us to algebraically manipulate so that it looks like a constant times a power function. Okay, so x to the 8/9 is in the bottom of the fraction. We can move it to the top by making it negative 8/9. And then we're still not taking an antiderivative, so we still need 53 over 54 out here. I guess I'm not sure. Yeah, that's got to be it. So they just wanted us to rewrite it. And now they want the general antiderivative. So whenever you take an antiderivative, the power goes up by 1. So negative 8/9 plus 1 is going to be a power of 1/9. Okay, I got extra parentheses. I don't think that'll matter. But when you take an antiderivative, you need to multiply by the reciprocal of the power, the new power that you get. 1/9 times 9 will make 1, just like it's supposed to here. And now they just want us to finally state the antiderivative. So negative 8/9 plus 1 is going to be x to the 1/9 power. And then we need to multiply by that reciprocal. So it's 53 over 54 times that 9 reciprocal that we were talking about in the earlier steps. So you could simplify it, but I don't think you need to. I think WebAssign is fine with that. No, oh, I forgot my arbitrary constant c. Because whenever you take an antiderivative, we need to put plus c because the derivative of this expression, plus 2, is still the original f of x. Plus 3, plus 4, minus 1, minus 2. It's arbitrary what constant you put in here, because when you take a derivative, constant makes 0.